Hello dear, welcome to my YouTube channel. Today we will learn about Umploung reaction. What does it? And many reaction generally we do or we write on the paper, but we do not consider these. We don't think that these are the Umploung reaction. We do not think criticals. Today I will define you these and we will learn about the Umploung reaction, and then we think that I missed that these are really Umpolung reactions. Let's start its content first. List of content: introduction, reversal of polarity, such Umpolung reaction is there. I mean, okay, let's start. Introduction. Umpolung reaction. What's Umpolung reaction? It is a nothing but it is a polarity inversion chemical modification of a functional group with aim of a reversal of polarity of that group. It's a nothing but it's a modification of the functional group. This modification allows secondary reaction of this functional group that would otherwise not be possible. This concept was introduced by DBH and EJ Corey. Actually, Umpolung reaction. In Umpolung reaction, what happens if we do not do the secondary reactions of that functionality? The Umpolung reaction would not be possible. So the basic need of the Umpolung reaction is to do the secondary reaction of that functionalities. So let's start with the functional groups. This is actually what carbonyl, this is about the carbonyl polarity or Umpolung reaction. Carbonyl is an electrophile at the carbon atom, hence it's susceptible to attack by the nucleophilic reagent. Thus carbonyl carbon react as a formyl cation or acyl cation. Let's traditional approach. What happens in traditional approach, that carbon of carbonyl is the electrophile because polarity is induced due to this electronegative atom oxygen. Then what happens? Electron concentration moves to the oxygen and leaves it as electropositive. Then it's susceptible to the nucleophilic attack. This is a traditional approach of the carbonyl. What happens? In Umpolung, a reversal of the positive polarity of carbonyl groups, so it acts as a formyl or acylene. In a traditional approach, what happens? Carbon acts as a carbonyl cation, formyl, it could be a formyl or acyl cation. When in Umpolung, the polarity of this reaction is reversed. Now it acts acyl anion or formyl anion. We have reactions. Now the carbonyl reactivity and target molecules. We may have a lot of functionalities and their position may be different. How can we differentiate whether Umpolung reaction has occurred or not in this compound? Such as we have traditional approach. What happens? Traditional approach, the carbon is electropositive, means it is a nucleophile, it is electrophile, sorry. And the second one is the anion, it means it would be a nucleophile, and third would be positive again. So the functionality position is a 1 3. Remember one thing in your mind, that when you have a traditional approach, the difference of carbon between two functionals would be odd carbon, such as we have one carbon here, 1 2 3 carbonyls. In an Umpolung reaction, it means reverse of polarity. Carbon is acting as anion, second carbon act as a cation, third one again anion. This is the reverse of this one. So Umploung reaction is a nothing but it is a inversion of polarity. Now inverted reactions, this is there's zero carbon between two functional group. Now here 1 2 even number of carbon between two functions. As I mentioned that how can we differentiate on the basis of functionality if functional groups are between in 1 3 position, then the it's a traditional approach. If the functional group are 1 2 1 4, then the reaction is Umploung function. Let's we do this easiest and general reactions of the carbonyls. What happens? Actually, you have seen many carbonyl reactions, and this is used as a protecting group of carbonyl acid is used. Now, what does it? It form the an acetal 1,3-dioxane, which has a pK value of 40, and thioacetal, which has a pK value of 30. Means this is a more acidic hydrogen than this one. The best choice would be thioacetal. So let's do an example. What happens in this? The carbon is attacked by the thioacetal. Now, due to the electronegativity of both sulfur groups, this is a acidic hydrogen. Now, what happens? This base abstract a proton and release a carbanion here. Then we do many reaction. We can this can attack on epoxy, this can attack on ketone, and this can react with alkyl halide. Actually, what happened? This carbonyl, this carbonyl is a positive, electropositive, and this is now electronegative atom. The this is a nucleophile, this is electrophile. The polarity of same carbon has been changed from positive to negative. Actually, how I changed? This is due to these secondary reaction. As I mentioned, as this would be possibly, when possible, allows secondary reactions, modification through secondary reaction. Let's giving an example. Other example, cyanide type Umploung. The Umploung reagent is a cyanide ion. The cyanide ion is usually in the that carbonyl triply bonded to a nitrogen would be expected to have a positive polarity due to high electronegativity of the nitrogen. Yet the negative charge of cyanide ion is a localized on carbon, giving it a formal negative charge. This ambivalence result in Umploung reaction. Many reaction where cyanide. Let's we have an example. This reaction is also known as state reactions. What happens? Carbonyl carbon is an electrophile, and this nucleophile attack an electrophile and abstract a proton. Now this hydrogen becomes acidic base pro abstract a proton, and this carbon acts as a nucleophile attack would attack an electrophile and abstract a proton, form a benzoin type reactions. Okay. Now actually what happened? And benzyl aldehyde carbon is electropositive, which is a electrophile, and here this is the nucleophile. The polarity of carbonyl carbon is changed from positive to negative. This is actually what we call Umploung reaction. As I mentioned you before that there are many reactions which we do not focus on their that they are, or we do not think critically So that's why we do not differentiate. You have seen many reactions of alkali halide, and you have done many alkali halide with triphenylphosphine, forming a yield Witting reaction. You might remember the Witting reaction. So actually what was carbon and what is now in this? Actually what happens? This is electronegative, this is electropositive, this is electrophile, this is a nucleophile. What happens here? It's a nucleophile, it's an electrophile. The polarity of the carbon is changed from positive to negative. Let's give an example. Other example. Here, X means alkali halide. You have done many reactions of Girganar reagent. Did you differentiate that, or have you thought that this could be Umpolung reactions when you had alkyl halides and you did reaction with a magnesium, and the polarity of this carbon is changed from positive to negative? Actually, we do not think critically, as I mentioned. If you would think critically, this would be differentiated by you. Here we are having another examples. Another simple reactions we might have done a lot of times. This is epoxidation of alkene. This is nucleophile, and these becomes electrophile. The polarity of carbon is changed from negative to positive. Now you might have been thinking there's small change we used previously. Carbon was positive and it was becoming negative, but here carbon is nucleophile and becomes electrophile. Same here. If you abstract a proton, this would be a negative charge. After bromination, this would be electrophile. A tremendous change. These are changes. These are the Umpolung reaction which we have discussed. If you want to discuss any more type of this reaction, you may discuss and you may learn. Thank you for watching my video.